Hi everyone, my name is Facheng Gong. Today I want to talk about my recent research. The topic is CFD DEM simulations of proppant transport in rough fractures. I'm working with Professor Huazhou Li and Professor Teifeng Papadakli. In hydraulic fracturing process, proppant are usually injected into the fracture to support it, and the regular sand dune will be formed in a smooth fracture. However, hydraulic fracturing usually creates rough fractures instead of smooth fracture. Due to the coupled particle fluid flow and the roughness feature, proppant transport phenomenon in rough fracture is much more complex than that in smooth fracture. The objective of this study is to review mechanisms of fluid granular interaction of proppant transport in rough fractures by numerical simulations. This shows the simulation results in a smooth fracture. This picture shows the comparison between the simulation result and the experimental result. Left is the experimental result. We can see that proppants are injected from left to right. Regular sand dune is formed on the bottom of the fracture. Right is the simulation result. We can see that simulation results agree well with experimental results, which validate the accuracy of the numerical model. Next, we present the procedures for generation of synthetic rough fracture surface. The fractional Brownian motion (FBM) method is used to generate a rough fracture. There are two main parameters for the generation of rough fractures: the Frankel dimension D and the random number seed. The Frankel dimension controls the roughness feature. The surface will have a larger roughness with a larger Frankel dimension. The random number seed controls the distribution of roughness. This shows the examples of rough fractures generated in the simulations. There are a total of 6 models: Model 1, Model 2, Model 3, and Model 4. They have the same random number seed, 1, but different Frankel dimension, 2.1, 2.2, 2.3, and 2.4. Model 4, Model 5, and Model 6, they have the same Frankel dimension, 2.4, but different random number seed, 1, 2, and 3. Next is the numerical model. In this study, the result CFDM approach is used to simulate proppant transport in rough fractures. For the CFD simulation, conservation of mass and momentum is used to describe fluid flow. For the DEM simulation, the Newton's law is used to describe particle movement. And the CFDM coupling is achieved through the calculation of particle fluid force and momentum. This shows comparison of simulation results for rough fractures with different Frankel dimensions. This picture shows the rough models number 1 to number 4 with Frankel dimension 2.1 to 2.4. We can see that different proppant distribution could be observed for fractures with different Frankel dimensions. This picture shows the proppant place patterns for rough fractures with Frankel dimension 2.2, 2.25, 2.3, and 2.35. It can be seen when the Frankel dimension increases to 2.25. There is a gradual transition from the regular sand dune to the irregular sand dune. Therefore, a larger Frankel dimension tends to facilitate the vertical movement of proppant and is beneficial to form a Frankel channel with a higher conductivity. This picture shows the change of proppant coverage ratio over time for the flat model and the rough model, number 1 to number 4. It can be observed proppant coverage ratio increases gradually with time for all 5 models. Also, the fracture with a higher Frankel dimension will have a higher proppant coverage ratio. This shows a comparison of simulation results for rough fractures with different random number seeds. This picture shows the rough model number 4 to number 6 with same Frank dimension 2.4 but with different random seed 1, 2, and 3. It can be seen, although most particles are jammed and inlet, Proppant distribution are different for different models. This shows Proppant placement patterns for rough fractures with random number seed 2 and with different Frank dimension from 2.2 to 2.35. Similarly, when the Frank dimension increases to 2.25, there is a gradual transition from the regular standard dune to the irregular standard dune. This picture shows the change of Proppant cover ratio over time for rough fractures number 4 to number 6. It can be seen the Proppant cover ratio for these three models are slightly different. We conclude for rough fractures is the Frank dimension determines the Proppant cover ratio, while the random number seed determines the Proppant distribution. This shows the simulation videos of two models with different Frank dimension 2.2 and 2.3. When the Frank dimension is small, like this model, the Frank dimension is 2.2, we can see most particles settle down on the bottom of the fracture. However, when the Frank dimension increases to 2.3, we can see that there are several Proppant clusters and the rough location of the fracture, and the Proppant cover ratio also increases. Therefore, there is a larger difference for models with different Frank dimensions. That's all I want to share. Thank you for your attention.